Okay, we are going to look at number 30. So a particle moves along a straight line from 0 to 5. The velocity of the particle is given as this function right here. The position of the particle is given by this. And at time 0, it is 10 units to the right. Okay, so just again, please note, the position is s of t. If we take the derivative of s of t, right, we get a velocity, which is given by v of t. And we are also told the initial condition is the point 0, 10, because 10 is positive, it means it's 10 to the right. So find all the values of t on the interval from 2 to 4, for which the speed of the particle is 2. So quick note, speed. Speed is the absolute value of the velocity, and here's why. When we talk about velocity, velocity gives us a number and a direction. So for example, if I told you the speed is 7 miles per hour, right? That doesn't tell you whether it's moving right or left. But if we talk about the velocity, I said the velocity is plus 7, what that would mean is it is 7 miles per hour to the right. If it was negative 7, it would be 7 miles per hour to the left. So velocity cares about direction, speed does not. Speed is just a number. So how do we express that here? The way we express that here is I want to know where does the speed equal to? And the way I'm going to find that is I'm going to say when does the absolute value of the velocity equal 2? And that occurs when the velocity equals 2 or when the velocity equals negative 2. Going to go through then solve those on my graphing calculator, and what I end up getting are two values. T equals 3.4734 or 3.473, or t equals 3.1276, which again we can truncate around. Okay, letter B. Write an expression involving an integral that gives the position s of t, then use it to find the position of the particle when t equals 5. So S of t, what is that going to be? Well, in order to determine S of t, we need an initial condition. So I need to say at time 0, its position is blank. And then to that, I'm going to add the displacement from time 0 to t, right? Whatever time we are looking for. We don't know right now. I mean, obviously, the second part of the question does give us a time, but right now I'm just trying to find a general formula where I could plug in any value for t. And we're going to be using our, that's going to be for our velocity function, except I'm not going to be using t here. I'm going to be using the letter x because I want them to be different, the t and the x to be different. Okay, so let's use this to evaluate our function. So if I want to find, let me move that down a little bit. If I want to find s of 5, right, that's going to be s of 0, which is 10, that was given, plus the definite integral from 0 to 5 of the function that we have, v of x dx. At this point, right, that is a calculator question. And what did I get? When I did it, I got this, negative 9.207. Let's move on. Letter C. So let's erase some of this so we can look at letter C. Okay. Boop, 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 boop. I don't want to see that. Get out of here. Okay, letter C. Find all the times t on the interval from 0 to 5 at which the particle changes direction. So a particle changes direction when the velocity, right, changes from positive to negative or negative to positive. So what am I going to do? I'm going to go and find all the critical values. So in other words, for letter C, the very first thing I'm going to do is I'm going to take the velocity function, which is given, and I'm going to set it equal to 0. And I got two values, okay? So I got one value is t equals 0.536, and the other value is t equals 3.177. I just truncated it. If you didn't, you would have gotten 3.178. Okay, so those are the two critical values I got. Now, of course, what I have to do, if you don't mind, I'm going to call this, well, just for our notes, I'm going to call this A and I'm going to call this B, and I'll show you why. Because I'm going to go, and this probably wouldn't be, I might not do this on the test itself, but I'm going to make a sign chart here, and I just want to make sure that they are changing directions, and I don't feel like writing those numbers over again. So to the left of 0.536 on my graphing calculator, I noticed that it was below, and then I noticed it went above, and then to the right of B, it went below. So what do I notice? I know that at the points A and B, the sign is changing direction. So there are 2 times from time 0 to 5 where the particle changes direction. So let's put that together in a, let's write our justification out here. Because again, sign chart's not going to work. So I'm going to say the particle changes directions 2 times. Let's say on the interval 0 to 5. At time t equals 0.536 and t equal, whoop, that's not t equals 3.177. At those times, s prime of t, which equals v of t, right? I'm pointing, I'm saying, hey, I'm looking at the v function, right? Changes sign. Okay? I should say at each of those times. I'm going to say at each of those times. I don't think it really matters, but I feel like it's a little bit better. So at each of those times, s prime of t equals v of t changes sign. If you wanted to be more specific, you could say, you know, at time t equals 0.536, it goes from negative to positive, and then at time t equals 3.177, it goes from positive to negative. Again, that's changing sign. Both are fine. Let's move on. Letter D. Is the speed of the particle decreasing or increasing or decreasing at time t equals 4? So when we talk about speed increasing or decreasing, in order to look at that, you have to look at both the velocity and the acceleration. So something is, reminder, something is speeding up when both the velocity and the acceleration of the function have the same sign. So if I say if the velocity is positive and the acceleration is positive, then it's speeding up. If the velocity is negative and the acceleration is negative, the object is still speeding up. If the signs are different, so the velocity is positive, the acceleration is negative, then the object is slowing down. So we're looking at the sign of both objects. So let's go and do that. So the first thing I'm going to do is I'm going to take v of t, and I'm going to evaluate it at 4, because they were asking us at 4. So when I take that v of t function, I get, and I evaluate it for, I get negative 11.475. The big thing here is that it's negative. Next, I'm going to take the derivative of this, right? Because that's going to give me the acceleration. And I'm going to evaluate it at 4. And what I'm going to notice? I'm going to get negative 22.957. Again, negative. Since both the velocity and the acceleration of the function are negative. In other words, they both have the same sign. The object is speeding up. So my justification is the object is speeding up at time t equals 4 because both the velocity and acceleration of the object have the same sign. And that is all there is to letter